Children, welcome back. Let us continue with our chapter Energy. In the previous video, we have discussed about the transformation of energy from one form to another. That is, energy can neither be created nor be destroyed, but can be transformed from one form to another. And we have studied some of the examples also. Now, we are moving on to our next topic, law of conservation of energy. Okay, so this is the fundamental law in physics, and the law is like this: whenever energy gets converted or transformed from one form to another form, the total energy remains unchanged. The lost energy in one form exactly reappears in another form, and the total energy remains unchanged. This is known as the law of conservation of energy. Okay, that is, we know that the energy can be converted from one form to another form, but the total energy is conserved. That is the law of conservation of energy. Okay, so let us study the examples and applications of the law. First one is the total energy of an oscillating pendulum remains unchanged. Thus, for an oscillating pendulum, kinetic energy changes into potential energy or vice versa, but the total sum of energy remains unchanged. In the picture, you can see a pendulum. We all know that the pendulum consists of a thread, a metal bob, and a rigid support. When it is in the undisturbed position, it will be just below the rigid support, isn't it? That is the position at A. When we are giving an oscillation or when we are giving a velocity to the metal bob, then it will possess the kinetic energy. That is, in the position A, it will possess the potential energy, and when we are giving a velocity B to the metal bob, it will changes to kinetic energy. Okay, when it is moving to the position B and it is reaching a height h, then what happened? The kinetic energy, that is, we can see that the position A to B, there is a slope, isn't it? So in that position, it is converting, the kinetic energy is converting to potential energy, and the kinetic energy becomes 0 at the position of B. Okay, when it reaches a position, maximum position at B, it will moves back and it is reaching a position C. Okay, so the from B to C, in the position B, it is having a potential energy, and when it is moving from B to C, it is again changing to kinetic energy. And when it is reaching the position C, what happened? It is the maximum height which can reach. Okay, so in that particular position, the kinetic energy will be 0 and it has the maximum potential energy. Okay, so from that position, it again comes to the next position, isn't it? So it is the oscillatory motion. So in this pendulum, we can see that the kinetic energy is converting to potential energy and vice versa. But we can say that the total energy remains unchanged. Next one is the motion of a roller coaster. We all enjoy the ride in a roller coaster, isn't it? So a roller coaster works on the principle that the energy of roller coaster car may change from kinetic energy to potential energy or vice versa, but the total energy of the car remains unchanged. So it works on the principle of the law of conservation of energy. Okay, so in the roller coaster, what is actually happening is that the roller coaster car, when it is sliding down, what happened? The potential energy is changing to kinetic energy and the car speeds up. When it is moving or moving in on a slope, what happened? That is from the position D to E, the car will slow down, isn't it? So in that position, the kinetic energy is changing to potential energy. Okay, so in the roller coaster, the motion of a roller coaster, we can see different position. We can see the potential energy as well as the kinetic energy. That is, it is frequently changing from potential energy to kinetic energy and vice versa. So, but the result is that the energy, that is the total energy, remains unchanged. Okay, so the motion of a roller coaster works, or it works on the principle of the law of conservation of energy. So the other applications we will discuss in the next video. Thank you. Keep watching, understand the concept, go through your textbook, keep safe in your home. Thank you.